with inverses, and the purpose of this video is to go through some of the problems on finding inverses of different types of functions. We've been doing linear functions, but I want to get into other, like, crazy ones. Like here we have like a fifth root and the fifth power, and so forth. And something like this that looks a little strange. It looks like these are called rational functions, like that kind of thing. So I want to get into those types of problems, and I'm probably going to add my own here because I'm seeing something that I'm not seeing. So anyhow, so one of the ways that we can state if the given functions are inverses of each other, if you recall, by definition, you have to show that f of g of x is equal to x and that g of f of x is equal to x. So if I'm over here and I want to find out, if these two functions are inverses of each other, by the way, you could always sketch these on Desmos, and you can certainly check to see if they reflect over the line y equals x. So that could be one of the first things that you would actually want to try to do, when you're assessing that. So that could be your visual way to do it, but this is algebra 2, so therefore we want to show these things algebraically. So the first thing, because I have f of g of x written first, I'm going to do f of, and I'm plugging in, whoops, that's a fifth power, right, minus 3. So everywhere I see an x in here, I am plugging this guy is getting plugged in everywhere I see an x down there. So that means that's going to be equal to the fifth root, say that with me, the fifth root of, you have a negative sign. Now remember, there's a negative, it's the opposite of whatever x is. Well, x is these two things, so therefore we have to do that and then put a minus 3 in thereafter. So now, when we go ahead and we do our magical stuff that we can do, we're going to distribute that negative sign through, and these become x to the fifth, negative, that's a negative, that becomes plus 3, minus 3, and if you look magically, the 3's disappear, and you wind up with the fifth root of x to the fifth, which is x. So that one works. So f of g of x works, but now we have to check to see that g of f of x works. It has to work both ways, because actually sometimes you're going to find that it'll work one way, but it's not going to work another way. So it's really important to check. All right, and I'll use a different color. So now we have g of f of x, so it's going to be g of the fifth root of negative x minus 3, because that's what f is, and we're plugging this everywhere we see an x up here for g. So now we have negative parentheses. This whole monster is going in here for x, so that's going to be negative x minus 3 raised to the fifth power, and that's minus 3. Now, if we do our order of operations, that negative sign right here is coming down. But if you look over here, we have the fifth root to the fifth power is telling us, be careful, the parentheses still stay there. So then this just becomes negative x minus 3, because the fifth root to the fifth are inverses of each other, and hence they undo one another, okay? So now we're going to distribute that negative sign through, and this becomes x plus 3 minus 3, which is equal to x. And that also checks out, which is perfect. So therefore, we can say that for number 1, the answer to this one is yes. They are inverses of each other, because we showed that going both ways, that they that it totally and completely works out. Now, I want to look at one of these other ones over here, like this crazy one right here, and I think it'll certainly help with the algebra. So if I do it, we're going to do f of g of x and g of f of x, and I have a feeling that this is going to get really nasty. So what I'm going to do is I am going to put in f of x equals, because I'm going to need some space, I could already tell you that, negative x minus 1, okay, over x minus 2, and then g of x is equal to, let's change this guy, go back a second, and that's going to be negative 2x plus 1, negative 2x plus 1 over, and that is negative x minus 1. I bet you guys remember that. I just didn't. Negative x minus 1. So now we're going to go ahead and do some crazy algebra to see how this all starts to work out. So I'm going to do f of g of x first. So I'm doing f of, and I'm going to do wherever I see an x, this is going in there. This is pretty nasty, but it's really good for us because, again, this is an algebra class. Okay, equals, so everywhere I see an x, I am going to put, I'm going to put that in there, okay? So now, and remember, you have to use parentheses. If you don't use parentheses, you're going to get into a lot of trouble. So for this x, all of this goes in for that x, and all of this goes in for this x. It'll be interesting to see how this all turns out. So let's go for the ride, shall we? So now instead of x, I'm going to put this big monstrosity in here, okay, over negative x minus 1, and then minus 1, right? And that's all over. And again, this monstrosity goes in here again. This is really going to tap into your algebra skills, by the way. I'm just warning you now. That's exactly what this is going to do. All right, so first things first, as I'm looking at something like this, I want to distribute the negative sign through, and the negative sign is really only going to impact the numerator of this ratio right here. So that's just going to wind up being 2x minus 1 over negative x minus 1 minus 1, and that's all over, and we have negative 2x plus 1 over negative x minus 1. And then there's that minus 2 there, right? So I'm staring at the same thing that you are. What I want you to do, and you would really impress me just so greatly, if you were to just focus on the numerator on its own, and if you were to just focus on the denominator on its own. If we were in class, I would tell you guys to get a common denominator up here. Down here, I would also tell you to do the same thing here. So what I'm going to do is we're going to get a common denominator for that guy. I didn't mean to put that in here. Here we go. And what we're going to do is, if I look at this, if I throw this over 1, negative x minus 1 is the common denominator. So I need some space down here. And it's going to be 2x minus 1 over negative x minus 1. And then it's going to be minus, and it's going to be negative x minus 1 over negative x minus 1. Because that's 1 over 1. I'm changing it to that because if you think about this, this whole thing is equal to 1. That's just your numerator. And then in the denominator, it feels like we're going to do the same thing here. So now we have negative 2x plus 1 over negative x minus 1. And then again, it's going to be minus, but it's going to be 2 times x minus 1. I'm sorry, negative x minus 1 over negative x minus 1, because those are your common denominators. So now when you go back upstairs, I want to show you something absolutely spectacular. You can combine these two. You can combine the numerators because your denominators are the same. So that's going to wind up being 2x minus 1 plus x plus 1, because I'm distributing the negative sign through both of those, and that's going to be all over negative x minus 1. And then divided by, over here, we're going to have negative 2x plus 1 plus, I'm looking over here, it's going to be plus 2x plus 2, because I'm distributing the negative sign to the 2 just upstairs and not downstairs. And then that's all over negative x minus 1, because that's what common denominators are. So now if we just tidy up the top and we tidy up the bottom, we get 3x just upstairs, right? Check that out. Negative x minus 1 over, check this out, we wind up with just 3 divided by negative x minus 1. And if we multiply by the reciprocal of this guy right here of negative x minus 1 over 3 times negative x minus 1 over 3, all of this cancels out to 1. These two cancel out, and you wind up with 3x over 3, which is just x. So we actually just showed that f of g of x is equal to x. I'm going to leave it to you guys by doing some crazy algebra on your own, as I want you guys to show if g of f of x is equal to x, because you're going to be doing a reflection on this video. So part of that is you're going to show me if g of f of x is equal to x for this function, for these two functions right here. So I'm going to ask you guys to do that just to see if you guys know, and then we'll definitely go over it when we meet live on Thursday. But this is as ugly as it's going to get, is showing, if g of f of x is equal to f of g of x. Okay? Now, so moving on, I want to take a look at, this is saying that you want to find the inverse of each function here, and it's all well and good, but there's something that I'm noticing on finding the inverse of all these functions here, and it's very disappointing to me. And one of the things that's disappointing to me is if I asked you guys, no, that's okay, we'll do it one step at a time. So let's say we want to find the inverse of this guy right here, okay? So we want to find the inverse of this function. So if you recall, we know that about inverses is that x and y switch, right? Because you're reflecting over the line y equals x. So if the point 2, 3 is on f, then the 0.3 comma 2 is going to be on its inverse. So now we want to go ahead and find its inverse, and remember, to find its inverse, we would just rewrite this as 4 minus the cube root of 4x, that should be a 4, all over 2. And then the first thing we do is we have to switch, because I just rewrote h of x as y. So now remember, we have to switch x with y, and we solve for y. Okay? Oh, this should be a 4y, not an x. Sorry about that, gang. Okay, should be a 4y, and that's all over 2. Now, the first step here is we want to multiply both sides by 2. So now we have 2x is equal to 4 minus the cube root of 4y. Now again, we're trying to solve for y, so I hope in those beautiful minds of yours you're like, let's subtract 4 from both sides, and we get 2x minus 4 is equal to the negative of the cube root of 4y. Don't like the negative here, so you know what we're going to do? Yes, we are going to divide both sides by -1, so this becomes negative 2x plus 4 is equal to the cube root of 4y. Now, to undo the cube root, we have to do what to both sides? You guessed it, we have to cube both sides. Cubey, right? So now the cube root of something cubed just leaves us with 4y is equal to, and now we have negative 2x plus 4 cubed. And now to finish it off, we're just going to divide both sides by 4. And now we have the inverse, which I'm going to call h inverse of x because I'm crazy, right? It's going to be negative 2x plus 4 to the third power divided by 4. Okay, so that takes care of that one. Let's say, for example, we want to find the inverse of number 19, okay? So again, remember, we have to switch x with y, blah, 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 blah. I strongly encourage you to go to Desmos and graph these to actually show that they are, in fact, inverses of one another. I am not going to do that. I'm going to leave you to do that because you need to go ahead that. So again, I'm going to add that to your repertoire. This will show that you're actually watching this. So show that these two, right? So you want to show, I'll even write it here, show these are inverses on Desmos, okay? All right, that's what you want to do. So now we're going to take this guy over here and we're going to go and we're going to find his inverse. So we have g of x is equal to negative x minus 1 cubed. I'm just going to go back and confirm that because that would just be annoying. Yes, it is. Oh, look at me go. Okay, so again, remember, this is your y. This is the same thing as y, so we can switch x with y to go find our inverse. Y minus 1 cubed. Again, don't like the negative sign. You have to divide everything out and just make sure things are all by themselves. So dividing both sides by a negative leaves us with this. Whoops, it's oh my God. Leaves us with this. And now we're ready to go. So now we can take the cube root of both sides. So we have the cube root of negative x is equal to the cube root of y minus 1 cubed, right? Actually, it should be more like, but it doesn't matter because everything works itself out. It should be like that. And what they're doing is they are physically undoing each other. So we have y minus 1, and now we can say that y is equal to the cube root of negative x plus 1. And that should be g inverse of x is equal to the cube root of negative x plus 1. And because I'm feeling generous right now, I think we're going to go ahead and we're going to graph those. So let's do cube root of negative x plus 1, and then the negative of x minus 3 cubed, x minus 1 cubed. Okay, so let's go to Des, right? We'll go to the Desmos, and here we are, Desmos, and we'll type that in here. If I were better prepared, I would have had this graphed already, but I'm just kind of doing it as we go along. So we're going to go f of x is equal to negative parentheses x minus 1 raised to the third power And then we're going to just call this one g of x because for some reason it doesn't like the notation. And we'll go here to the keyboard, and we'll go to functions, and we'll go to this one here, miscellaneous. And right there, you see that? You can pick whatever root. We're talking about the cube root this time, negative x, and then, what is that, plus 1, okay? Negative x plus 1. So now, let's see what's going on here. So let's go ahead. All right. Oops. Does it not like what I have here? Oh, I must have hit something there. I don't know what happened, but okay. So now if we type in y equals x, right? If we type in y equals x, and let's go here, we have this point 1, 0. This point is 0, 1. This point is 1.536, negative blah, 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 blah. So check it out. Again, they're reflecting over the line y equals x, so you can actually show that those are inverses. And by the way, you could do f of g of x is equal to x, and g of f of x is equal to x. You can also show that, okay? So, with that said, I want to move on to the next one. Okay. All right. And I want to get into something where we have to actually do a domain restriction. Okay. There's nothing on this sheet that I noticed that actually has a domain restriction on it. So here's the thing. So I want to do something where we have to find the inverse. Let's get crazy. Oops. We'll go to a new one. That's annoying. So I want to find the inverse of f of x. This is a good one. I'm happy I'm doing this one. Okay. X plus 2 squared plus 1. Okay? So if I were to look at this graph, right, and I asked you guys, what's the vertex? The first thing you knuckleheads should say, okay, for starters, this is a parabola whose vertex is at negative 2, comma 1, right? Now, if you go to plot that function, and we're over here at negative 2, comma 1, we're going to have something that looks like this, right? And here we are at negative 2, comma 1. And you should be saying to yourself right now, self, all of a sudden, I already know that this does not pass the horizontal line test. So therefore, we have to, yes, you agree, restrict the domain. So if you look at the domain restriction, that means you can pick either the right side of the parabola or you can pick the left side of the parabola. So at this point, what I'm going to do, just to be crazy and just to be cool, I'm going to pick the left side of the parabola. So when I say find the inverse of f of x equals blah, 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 I'm going to say domain restriction, or I'm going to have to say domain restriction. Check this out. I don't have to say domain restriction. I'm just going to write my domain restriction where x is less than or equal to negative 2, okay? Because that's where the vertex is. When you restrict your domain for parabolas, it always makes sense to restrict the domain at the vertex, okay? Less than or equal to negative 2. Here we go. I'm just getting so sloppy in my old age, so that means I want everything to the left of this, right? Okay. So now we're actually going to go get the, oh my God, English, Charlene, the inverse. Okay, I don't know why I had a meltdown there. I just did. Okay, so now we know, before we go and find the inverse, let's just use our heads a little bit, right? So if I were to put negative 3 into this function, right, negative 3 plus 2 is negative 1 squared is 1, and 1 is 2. So I know that negative 3, comma 2 is on that graph. If I were to put negative 4 in here, I would have negative 4 plus 2 is negative 2 squared is 4 plus 1 is 5. So I know that this is negative 4, comma 5. Now, in your beautiful minds, you should be thinking, wow, if negative 4, comma 5 is on there, right, that you know that, if f of negative 4 is equal to 5, then you know that f inverse of 5 is equal to negative 4. Right? So you know that on the inverse, the point 5, comma negative 4 is going to be on there, the point, comma 2, negative 3, 1, and then negative 2, and so forth, okay? So I want to show you something from an algebraic perspective. So now we're actually going to go and get the inverse. So I'm going to switch x and y immediately. So we're going to get the inverse. So now we have x is equal to y plus 2 squared plus 1. And we're going to solve this out. We're going to subtract 1 from both sides. And here we are, right? Squared. Now, this looks super familiar, right? But here's the thing. When you take the square root of both sides, what do you remember? Yes, you get two solutions. You get plus or minus the square root of x minus 1 is equal to, y plus 2 squared. So you're just going to have y plus 2 is equal to plus or minus the square root of x minus 1, and I'm sorry, x minus 1, my goodness, x minus 1, because I already was subtracting the 2 in my head, that's over there, x minus 1, and then finally we have plus or minus the square root of x minus 1 minus 2 is equal to y. You should know that there are two functions here, right? There are two of them. We have y is equal to the square root of x minus 1 minus 2, or we have y is equal to the negative of x minus 1 minus 2. So that means then we have to choose between these two. Which one do we want, right? Which one of these functions is the actual, inverse of f of x equals x plus 2 quantity squared, where your domain is less than or equal to negative 2. So we're talking about the left half of the parabola, right? Now, if you look at this, the thing is this is a positive square root, so it's going to be a positive eyebrow. This is a negative square root, so it's going to be going that away. So if you were to look at this, and this is your half of the graph, right? In your beautiful minds, you know that the point 1 comma negative 2 is on here, right? 2 comma negative 3 is on here. 4 negative 5 is on here, and it's going to look something like this. So in your beautiful minds, this should be the one that we're talking about. So if I say to you, who is the inverse of the parabola when you're doing that half, you're going to say f inverse of x is equal to the negative square root of x minus 1 minus 2. So that is the inverse of that when your domain restriction is less than or equal to 2. Now, what I want to allude you to is that if you at the beginning said, I'm going to let my domain restriction be greater than or equal to 2, well, then it would be that half of the parabola right there, and it would be this one here. So I'm going to go ahead and show you what I mean by that when we jump into Desmos, right? So we have x plus 2 squared plus 1, and then we have plus or minus the square root of x minus 1 minus 2. Okay, so let's go right into Desmos, and then let's take a look at this so you can actually see what the heck I'm talking about. All right, I'm going to leave that y equals x on. So now I have f of x is equal to x, I'm so happy I wrote that down, plus 2 squared, right, plus 1. Now remember, we put that domain restriction when x is, check it out, less than or equal to negative 2, right? There it is, so you can actually see it. And then, so if I were to graph g of x as his negative equals negative, I could actually type in square root of x minus 1, and then do a minus 2. So what I'm going to do here is you can actually see that if I were to pick this point here, right, 2, negative 3, right, if there was 2, I just had it, 2, negative 3, then you know that, where am I? I don't feel like graphing it, but you can actually see that the left half of the parabola, it actually reflects over quite nicely. And then if we were to do it the other way, so I'm just going to copy this, Control copy, oops, Command Z, hold on, I'm sure, does this let me copy? I hope it does. All right, Control Z, good. And if I did this here, if I changed it this way, and I did this instead, right, I'm going to turn, oh, I like that it's a different color. And then if I were to graph this guy here, Control copy, collapse, I don't need you, Control V, and if I were to do the positive half of him, check it out, okay? So what's really cool is depending upon how we restrict the domain, so if you look at these two functions right here, these two functions correspond to the purple graph and to the black graph, and you can actually see they reflect over that line. Or, you know, somebody can be like, well, I want the positive half of the parabola. That means you have to take the positive square root. So think about it. The left half of the parabola is technically the negative side, so therefore it gets the negative inverse, right? The positive half of the parabola gets the positive side, so therefore it gets the positive half of the parabola. So when we're doing even function, so if it's an even degree function, then we have to be sure, because that also works with fourth degrees. It also works with sixth degrees and all that jazz. So these are the things that I want you guys to start thinking of. And then as we move forward and we meet up on Thursday, you guys are going to, mess around with some problems, find some inverses on your own, and then we'll just kind of take things up a notch from there and see how you make out. I hope that this proved fruitful. And yeah, I'm around for questions.